Hello, how to quickly solve this nice math problem, and I'm going to tell you the simple reason why you never learn this in school. Taking for instance, if you have 2 to the power of 5 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2, and this is 2 times 2 4 times 2 8 times 2 16 times 2 32. This is equal to 32. Then but 5 base 2 is not equal to 2 to the power of 5. Now, the whole of this is called tetration, which simply means a power height of 5 with a base of 2. And this equation, this means 2 is tetrated to 5. Simply means 2 is tetrated to 5. Now let's compute this. If you have 3 to the power of 3, this is equal to 3 multiplied by 3 multiplied by 3, and this is 27. Now if you have 10 to the power of 3, this is equal to 10 multiplied by 10 multiplied by 10. This is equal to 10 times 10 100, 100 times 10, that is 1000. Now if you now have 2 tetrated to 5, this is equal to 2 to the power of 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 2. Can you see the difference? Then now let's work with this 2 exponent first. 2 to the power of 2 is equal to 4, and this implies that we have 2 to the power of 2 to the power of 2 to the power of 4. Now let's work with this 2 again. Then 2 to the power of 4 is equal to 16. Then we have 2 to the power of 2 to the power of 16. Now we can see. Now let's work with these 2 again. 2 to the power of 16 is equal to 655 36. And lastly, we have 2 to the power of 655 36. And you can see that in order to operate this, compute this, is going to be very large. And of course, this is vastly larger than many physical quantities we may deal with, like numbers of atoms in the observable universe. So you can see how large this number is going to be. So that is why you never learn this in school. As you can see, this 2 to the power of 65536, as larger as it is, simply means that it is vastly larger than many physical quantities we deal with, like numbers of atoms in observable universe. That is how large these numbers is going to be. So that is why you see that you never learn this in school. Now let's consider another one. Now if you have 3 tetrated to 4, this simply means 3 is tetrated to 4. Then 3 tetrated to 4 is equal to 3 to the power of 3 to the power of 3 to the power of 3. Then in the same way, we can consider these two upper exponents, these two last exponents, that is 3 to the power of 3 is equal to 27. Now this is 3 to the power of 3 to the power of 27. Now let's consider this 2 again. Then 3 to the power of 27 is equal to 76, 25, 59, 74, 84, 987. You can see how large this is. Now the last part is we have 3 to the power of 76, 255, 974, 84, 987. Now to compute this, you will discover that your calculator will not even take this. And then since this is very large, we can then conclude that this is comprehensively large and can be computed directly in standard arithmetics due to its large size. So we see that it's very, very large, and this can be computed directly, so in standard arithmetics. So that is why you see that you never learn this in school. If you learn this, how are we going to compute this? So that is why you never learn this in school. Now let's check another example again. Taking for instance, if you have 2 titrated to 3, then this is not equal to 2 to the power of 3. And let's compute this now. 2 titrated to 3 is equal to 2 to the power of 2 to the power of 2. That is 2 in 3 places. Then let's consider this. 2 to the power of 2 is equal to 4. Now this is 2 to the power of 4. And now 2 to the power of 4 is what? Is equal to 16. You can see that this is more simple. So, and so on and so forth. Now, if you think you understand this, so I want you to compute this and tell me the answer in the comment section. Compute this. Four tetrated to 3. And show your answer in the comment section. So I want to know, show me the answer or tell me the answer in the comment section. 4 tetrated to 3. So what is the answer? I hope you enjoyed this video. Thank you for watching. Please don't forget to like, share, comment, and subscribe to my channel. So this is what I want to teach you about tetration. So with these 3 examples, I can see that tetration is not as difficult as the way they would think, but due to its large values of numbers or due to its large size, that is why you never learn about this in school. Thank you. Bye.